Welcome to Dermatology Explained. Today's video presentation is the next video in the Drugs in Dermatology series, and our focus today is on topical retinoids, and there is also a brief segment on cosmetic retinols. Topical retinoids are a class of molecules derived from vitamin A. It is a fat-soluble organic compound, and its metabolites are involved in immune function, reproduction, vision, cellular communication, and differentiation. Topical retinoids has been approved by the FDA for more than 4 decades, with tretinoin being the first approved topical retinoid used in acne vulgaris in 1971. Topical retinoids have a number of benefits on the skin, and it works by increasing skin cell turnover, preventing pores from clogging, inhibiting abnormal proliferation of keratinocytes. It can reduce inflammation, reduce and prevent acne scars. It can boost collagen and thereby increase skin tone and reduce fine lines and wrinkles. It can reduce sebum production associated with acne, and it also can suppress melanocytes, thereby improving the pigmentation of the skin. As a recap, where do we get retinoids from typically, and where does it get stored in the body? So there is 2 key sources of retinoids in humans, since vitamin A cannot be produced inside the human body. The first source is from retinol, or vitamin A, from a variety of sources, including milk, eggs, cheeses, liver. And the other key source is from a precursor called carotene, which is found in green and yellow leafy vegetables, as seen here. Carotene is a precursor and it gets converted to retinol. Retinol, once ingested, whether it's from the primary sources or whether it's from carotene, once it's ingested inside the human body, it gets combined with chylomicron and gets transported and stored into the liver, where it undergoes processing, such as esterification, and it gets stored. And 90% of the retinol is stored in the liver. However, a portion of retinol is stored in other areas of the body. And in the skin, it gets converted and stored in a form called retinol esters, which is an inactive form of the retinoid. Now, vitamin A derivatives exist in multiple forms. It includes retinol esters, which is the predominant form in the skin. It also includes retinol, which is involved in reproduction and embryonic development. It is also stored in an aldehyde form known as retinaldehyde or retinal, which has involvement in vision pathway development. And it is also formed in an active form called retinoic acid, which it plays a key role in epidermal skin differentiation and growth. So how do these derivatives relate to each other? Their relationship with each other is that they can be converted from one form to another. So the predominant form in the skin is retinol ester, as you can see on the left-hand side here. It is an inactive form of vitamin A and has the least potency and has limited efficacy and absorption. Retinol ester can be converted into retinol, which is the most studied vitamin A derivative. Retinol can then be converted into retinaldehyde, and retinaldehyde can then be converted to retinoic acid, which is the active form of vitamin A, and it is the most potent. So generally speaking, retinol ester, to go from the inactive to active state, has to go through 3 conversions, and therefore only a small amount of it gets converted into the active form, and therefore it is the least potent. Whereas, in comparison, retinaldehyde, or retinal, only has to undergo 1 conversion step, and therefore, generally speaking, it is considered more potent compared to retinol ester. It should be noted that although retinol can be found in natural forms from animal and plant sources, most commercially available retinol products are actually produced synthetically in the lab. What are the indications for topical retinoids? Topical retinoids can be used to treat a number of medical conditions, including acne vulgaris. It can be used to treat fine wrinkling, hyperpigmentation changes, as well as the roughness of facial skin. Some specific topical retinoids, such as tazarotene, is used in psoriasis. Alitretinoin is used in Kaposi sarcoma, and bexarotene is used in cutaneous T-cell lymphoma. There are also a number of off-label uses of topical retinoids, including actinic keratoses, hyperpigmentation disorders such as melasma and solar lentiginous, a various number of hyperkeratotic disorders. It can be used as pre-treatment of skin to augment wound healing, and it is also used in early stretch marks and abdominal striae. What is the mechanism of action of topical retinoids? This diagram demonstrates the cellular mechanism of the retinoid action. The retinol or alternative retinoid metabolites have to be taken up from the blood into the nucleus, where it can act on to upregulate specific genes that carry out the function of retinol. How does the retinol molecule go from the blood into the nucleus? Well, it needs to be transported across the cell membrane. So how it does that is the retinol, once it goes past the cell membrane, it gets attached to a transporter molecule called CRABP, CRABP, which stands for cytosolic retinoic acid binding protein. So CRABP binds retinol and is able to bring it into the nucleus, where it is then able to bind to its target receptors, so the retinoic acid receptors. The receptors exist as RXR or RXA, and by binding and activating these receptors, it essentially acts as a transcription factor to activate the promoter gene, which is RARE, or retinoic acid response element. And by activating RARE, it activates transcription of the target gene and allows upregulation of the appropriate relevant pathways and downregulation of the appropriate relevant pathways that allow the retinol to work. And so I have developed an analogy to help understand this on a more basic level. So let's pretend our retinol molecule is Mr. Retinoid, Batman's cousin. So Mr. Retinoid needs to be able to get to his Batmobile, in this case, the rare Batmobile, or retinoic acid response element Batmobile, in order to do what he needs to do. So how does he transverse the cell membrane and get to the nucleus, which is where the Batmobile exists? Well, he needs to be transported there. And the way he gets transported is using his transporter vehicle, which is shown here, CRAB-P, or cytosolic retinoic acid binding protein, or which is the transporter for Mr. Retinoid. So once Mr. Retinoid is able to bind to cytosolic retinoic acid binding protein, he's able to get through the cell membrane and go to the island, the nucleus island, to meet with his rare car. Once he gets to the rare car, he needs to be able to activate and turn on the engine of the rare car in order to activate the pathways that's involved in the function of retinoids. And in order to do that, he needs to activate the engine with a key. And in this case, it's the retinoic acid receptors, which is RXR or RAR. And by activating the engine with the key, we're able to activate the rare car, turn on the rare Batmobile, and allow it to function and work. And that is what happens. And this allows the biological effects of retinoids, which is listed here in this table. And as you know, it is involved in embryonic growth, morphogenesis, differentiation and maintenance of epithelial tissues, reproduction in the case of retinol, visual function in the case of retinaldehyde, as well as multiple effects on the skin, including anti-keratinization, modulation or proliferation and differentiation, anti-acne effects, anti-seborrheic effects, anti-inflammatory effects, and positive effects on collagen synthesis. This is my analogy for how retinoids work in terms of their mechanism. In terms of the classes of topical retinoid medications, there are 6 key classes of medications, and this includes tretinoin, which is otherwise known as all-trans retinoic acid. It includes adapalene, tazarotene, trifarotene, which is the latest 4th generation topical retinoid, alitretinoin, as well as bexarotene. Tretinoin has indications for acne, as well as photoaging and retinoids. Tazarotene is indicated for psoriasis, and it works by regulating cell proliferation and inflammation. Adapalene and trifarotene has been approved for acne vulgaris. Alitretinoin and bexarotene topical use is very limited, and it usually needs to be compounded. And it's used in rarer cases, such as Kaposi sarcoma, as well as select cases of cutaneous T-cell lymphoma. So how do these classes of topical retinoids differ? They differ primarily on where they bind to in terms of their retinoic acid targets. And in order to understand the targets, we need to understand the distribution of the different type of receptors. So I'd like to draw your attention to this diagram of the skin layers on the left-hand side. We can see here, this diagram shows the 3 key layers, the epidermis, the dermis, and the hypodermis and subcutaneous tissues. And the diagram also demonstrates the distribution of the retinoic acid receptors. We can see here for retinoic acid receptor subtype alpha, that is distributed in both the epidermis and dermis. So it's quite widespread throughout the top two layers of the skin. Retinoic acid receptor gamma is predominantly localized to the top layer of the skin, so the epidermis, whereas retinoic acid receptor beta is located only in the dermis. We also have retinoic X receptor, so RXR alpha, which is only located in the epidermis. Now, I'd like to draw your attention down here to the labels of the stars, which correspond to different classes of the topical retinoids. We can see here that tretinoin binds to all three types of retinoic acid receptors. So it binds to retinoic acid receptor alpha, beta, and gamma. So it acts throughout the epidermis and dermis. Adapalene binds to retinoic acid receptor gamma and beta. Gamma located in the epidermis and beta located in the dermis. Tazarotene acts on retinoic acid receptor gamma and beta as well, which is in epidermis and dermis. Now, the newer fourth generation topical retinoid trifarotene only acts on retinoic acid receptor gamma, which is only located in the epidermis. And so therefore it doesn't act on the retinoic acid receptors in the lower layer of the skin. And there has been some support for trifarotene having a lesser side effect profile. The reason being is it acts very selectively on retinoic acid receptors only located in the epidermis, where it has its focal impact on acne. As such, we can see here that receptor subtypes carry different affinity levels for various topical retinoids, which results in differences in their potency, tolerability, and efficacy of each topical retinoid agent. Now, to further detail about each generation of topical retinoids, for the first generation of topical retinoids, we have tretinoin, which is all trans-retinoic acid. It is commonly found in strengths 0.025% to 0.1%. And it is indicated for acne vulgaris, photoaging, and retides, and fine lines. There are also off-label uses as well, including conditions such as keratosis pilaris, actinic keratoses, and hyperpigmentation disorders such as melasma and solar lentiginous. Although it is more cost-effective, it is considered more slightly irritating compared to other topical retinoids, and it is also less stable. It is inactivated by UV light, and therefore it is recommended that tretinoin is used at night rather than in the daytime. It is also oxidized and inactivated by benzoyl peroxide, and therefore it is recommended that tretinoin is not combined with and not used concurrently with benzoyl peroxide. Tretinoin can be found in combination product with clindamycin commercially and is used for the treatment of acne. Because tretinoin activates all three subtypes of the retinoic acid receptor, so all three alpha, beta, and gamma subtypes, it is considered one of the more powerful types of topical retinoid medications. However, it has more irritating side effects. There are no second-generation topical retinoids. In terms of third-generation topical retinoids, there is tazarotene and adapalene. Tazarotene has been approved for usage in acne vulgaris and plaque psoriasis, and its concentrations is typically 0.05% or 0.1%. It is also one of the strongest topical retinoids, so much so that it has a pregnancy category X. Adapalene has been approved for acne vulgaris, and one of the key brand names is different. It is also used off-label for a number of other disorders, including hyperpigmentation, actinic keratoses, photoaging, and retides. Because it only activates the beta and gamma subtypes of retinoic acid receptors, rather than all three subtypes, it's thought to be less irritating and less prone to photodegradation, and is considered more chemically stable. This is why it can be combined with benzoyl peroxide in a combination product to be used in acne vulgaris, which contrasts with the first generation retinoid, tretinoin. So just to reiterate, adapalene has theoretically better stability in light as well as lessened skin irritation side effects compared to the first generation topical retinoid, tretinoin. Then there is the fourth generation topical retinoids, trifarotene, which has been approved for acne vulgaris. It has very selective binding towards the gamma subtype of retinoic acid receptor, which is located only in the epidermis. And as such, it theoretically has lesser and minimal systemic absorption compared to the other types of topical retinoids. In the USA, it is also approved for ichthyotic conditions such as lamellar ichthyosis, and it is used off-label in a number of other conditions such as congenital ichthyoses, including recessive X-linked ichthyosis, epidermolytic ichthyosis, as well as erythrokeratoderma variabilis. There are a number of precautions and adverse effects to be aware of when using topical retinoids, and some of these contraindications and adverse events are summarized in this table. We can see here that generally speaking across the board, topical retinoids are associated with irritation of the skin, redness or erythema of the skin, and can result in peeling and at times temporary worsening of the acne. It could also result in a burning sensation and increased photosensitivity of the skin to the sun, and thus we should advise our patients to be very vigilant with their sun protection and ideally use topical retinoids at night rather than during the daytime. It can also be associated with carbonization of psoriasis, and in some instances such as alitretinoin and bexarotene, it can be associated with itchiness and pruritus. It's important to highlight again that tazarotene is category X medication and should not at all be used during pregnancy. There's also a number of drug interactions to be aware of as well. Oral trans-retinoic acid or tretinoin, this should not be used in combination with benzoyl peroxide as it is neutralized in terms of its function. What are the benefits of topical retinoids? Because of its favorable safety profile, it is often used as an alternative to oral retinoids where appropriate. It is effective for mild comedonal and mild papulopustular acne, and it can be used for maintenance treatment of acne after someone completes a course of oral retinoids, such as isotretinoin. It can reverse some features of photoaging, photodamage, and improve post-inflammatory hyperpigmentation. It can also enhance the efficacy of other topical medications applied, such as 5-fluorouracil cream for actinic keratoses or intraepidermal carcinoma, or hydroquinone in the case of bleaching creams. Now I will touch on cosmetic retinols and their comparison to prescription retinoids. This topic is important as a lot of patients will approach their skin doctor or dermatologist with questions with regards to various different cosmetic retinols on the market, and it is important to have an understanding of the underlying science with regards to these products. So I refer back to this flowchart diagram again, which demonstrates the vitamin A derivatives. To re-emphasize, it can exist in retinol ester form, which is the most predominant natural form in the skin, and that is the least potent form. That can be converted into retinol, which is used in a lot of pharmaceutical cosmetic retinoid products. That can be converted into retinaldehyde, which can then be converted into retinoic acid. And it is retinoic acid which is the more potent form and the biologically active form. When someone is prescribed retinol, the retinol medication needs to be converted to retinoic acid in the skin in order to see the results. And it's only a proportion of the retinol that gets converted. Because there's multiple steps required in the conversion process, only a small amount ends up becoming biologically active. So therefore, retinol is not as strong, doesn't have the same impact on the skin compared to retinoic acid. However, the upside of that is that theoretically, it will have fewer unwanted side effects, such as redness, peeling, and dry skin. Retinol also quite unstable in UV light, which is why the way that product is formulated and packaged is important to ensure its efficacy. The delivery system, once the bottle or jar is opened on the shelf, will also determine how long it lasts, meaning if the formula is exposed to light and air, it may lose potency more rapidly than compared to, say, for example, an airtight pump. So you may ask, why not just use retinoic acid rather than use retinol or retinaldehyde? Retinoic acid is the most potent product compared to over-the-counter products. However, it also means it has the greatest side effects, including dryness, peeling, and irritation. And therefore, generally speaking, when prescribing medications, we can start low and slow, start with a weaker product, and up titrate as tolerated. There is also a relatively new ingredient called hydroxypinacolone retinoate, HPR, which is an ester of retinoic acid. It's an ester of retinoic acid, not an ester of retinol. So theoretically, the conversion of hydroxypinacolone retinoate to retinoic acid is just a single conversion step. And manufacturers have reported lower irritation of this product compared to the same concentration of retinol. Although it does sound promising and is already found in several skincare products, there is a lack of independent studies at the moment to further test and verify these claims. And so it is in watch this space mode. What are some tips and tricks you can recommend for patients when it comes to cosmeceutical retinol products? Firstly, use a retinol base suitable for your skin type. If you have dry skin or sensitive skin, a cream base is preferred. If you have resistant skin, then using a serum base, which proffers a higher concentration of active ingredient in a smaller volume, which is less occlusive, might be more appropriate. Since they are quite thin and light, the serum can penetrate the skin more efficiently compared to creams. And since they're grease-free, serums work well in people with oily skin. Tip number 2, start retinoids low and slow. So instead of going straight in and using retinoids every night and every day, that can create a significant irritation to the skin, particularly when it's not used to the medication. So therefore, it's recommended one starts every second night or even every third night, and to use the retinoid at this frequency for a period of time. And once the skin adapts and gets used to it, we can slowly increase the frequency as tolerated. It should be used after a bath or shower, and a pea-sized amount should be applied. And once skin tolerance is built up, the frequency can then be slowly increased. Tip number 3, what can you use with retinol? You can use other agents such as niacinamide, and particularly for patients with inflammatory skin lesions due to acne or rosacea, applying azelaic acid can be useful and helpful in these instances. Retinoids can be used concurrently with moisturizers to reduce irritation. And this is particularly important because retinoids is associated with peeling, drying, and flaking when you first start using it. Tip number 4, what to avoid using concurrently with retinoids. Because retinoid medications are very irritating themselves, it's important to avoid other topicals which can be irritating to the skin, such as other acids, including vitamin C. One way to get around this is using vitamin C in the morning and then followed by using retinoid at night, rather than using these two topical products at the same time, which can create a significant irritating effect on the skin. Other acid topicals, such as alpha-hydroxy acids, should be avoided using concurrently with retinoids, and this includes lactic acid, glycolic acid, and mandelic acid. And retinoids should be avoided using with benzoyl peroxide, such as Benzac wash, as the benzoyl peroxide can have a neutralizing effect on the retinoid medication. Next tip, what happens when the skin is really irritated after using the retinoids, also known as retinol burn? It's important in this instance to take a break and to stop the retinoid and to apply moisturizers and Vaseline until the skin calms down and improves. Once the irritation has settled, the retinoid can be retried again, but it's important to reintroduce it at a low and slow pace, such as once a week or twice a week, until the skin adapts and get used to it, and then you can build up the frequency as tolerated. If there is persisting inflammation, it's important to seek medical advice. It may be a contact allergy to an ingredient in the retinol or retinaldehyde medication, or else it could be an irritant contact dermatitis to one of the ingredients in the vehicle or in the formulation of the retinol medication. In some instances, topical steroids may be required to settle the inflammation associated with the use of topical retinoids. So in summary, topical retinoids can have an extremely important role in dermatology care. However, it also has significant side effects as well when not used judiciously. And it's important to remember the great advice provided to Spider-Man: with great power comes great responsibility. Thank you for joining me in this video presentation today on topical retinoids. I've hoped you've learned something interesting and useful, and we look forward to meeting again in the next video presentation.